Welcome to Space to Ground. I'm Shaniqua Vereen. In an exciting display of precision and teamwork, Dragon Freedom undocked from the forward port of the Harmony module, making room for the anticipated Cargo Dragon resupply ship that launched Monday, November 4th.
Freedom SpaceX, all hooks
On November 3rd, the Crew 9 Dragon capsule carrying its 4 astronauts successfully undocked from the International Space Station at precisely 6:35 a.m. Eastern. Just under an hour later, they redocked, transitioning from the forward-facing port of Harmony to the space-facing Zenith port. But why was the relocation of the Crew Dragon necessary in the first place? We received that hashtag Ask NASA question from @Pottery4Life. So, what is the benefit for the relocation of the Crew Dragon for the purpose of giving the forward port to the Cargo Dragon? Well, the relocation was necessary so that the CRS-31 Dragon cargo spacecraft can provide a reboost in altitude to the space station. That reboost can only happen from the forward-facing port of the Harmony module. Docking to the Zenith port, where the Crew 8 Dragon was located, would lower the orbit versus raising it.
Base to ground.
On Monday, November 4th, NASA and SpaceX launched the 31st resupply mission from Florida, delivering scientific investigations, supplies, and equipment to the space station, including research involving studies of solar wind, a radiation-tolerant moss, spacecraft materials, and cold welding in space. Did you know that different mosses grow on every continent on Earth and have the highest radiation tolerance of any plant? Their small size and low maintenance, ability to absorb water from the air, and tolerance of harsh conditions make them suitable for spaceflight. An experiment called Artemis observes the combined effects of microgravity and cosmic radiation. Researchers will look to identify genes that drive adaptations to sustain life in extreme environments. There's been little research on how these two factors together affect plant physiology and performance, and results could help identify biological systems suitable for use in bioregenerative life support systems on future missions. NASA chose the Antarctic moss because the continent receives high levels of radiation from the sun. Plants and other biological systems able to withstand the extreme conditions of space also could provide food and other necessities in harsh environments on Earth. You can follow more exciting developments and updates on the International Space Station by visiting blogs.nasa.gov/space station. And that's Space to Ground for this week. Thanks for watching.